Hello everyone, I welcome you all. This is Lata working as an assistant professor in the Department of Chemistry at KVN Arts, Commerce and Science College, Canada Corner, Nasik. In today's lecture, we are going to discuss about the biosynthesis of alpha-terpenin, gamma-terpenin, terpenin for all, sabinin, thuzone, thugene, and cineole from NPP. Now we will see the synthesis of alpha-terpenin, gamma-terpenin and terpenin for all from the NPP. So from NPP, this is structure of NPP. In NPP first step, on loss of OPP, we use this allylic cation. In next step, these pi bond attack on this electrons deficient carbon atom and we get 6-member ring with this double bond and this carbocation. In next step, hydrogen shift occurs. This hydrogen shifted over here and there is a formation of new tertiary carbocation, and after hydrolysis we get terpene for all. Whenever you shift this proton here, then we get here double bond and here double bond, and this is called as alpha-terpenin. And instead of this proton, you can shift this hydrogen over here. Here hydrogen shift. We get here is double bond and here is double bond, and this is called as gamma terpenin. Now we will see the synthesis of sabinin from NPP. So the first, write down the structure of NPP. In first step, loss of OPP take place and we get allylic cation. In next step, this pi bond attack on this electron deficient carbon atom and we get 6-member ring with this positive charge and this double bond. In next step, hydrogen shift take place of this hydrogen and we get here new tertiary cation with this double bond. In next step, these pi bond attack on this electron deficient carbon atom and we get this new carbon-carbon bond and with this tertiary carbocation. In next step, minus H plus of this proton and we get here a double bond, here a carbon-carbon single bond. This cation is called as a fusyl cation and this compound is called as a sabinin. Next we will see the synthesis of thuzene and thuzone from NPP. So the structure of NPP here is double bond, here OPP. So in first step, loss of OPP take place and we get allylic cation. In next step, these pi bond attack on this electron deficient carbon atom and we get 6-member ring with this carbocation and double bond. In next step, 1,2 hydrogen shift take place of this hydrogen on this carbon atom and we get new tertiary carbocation, here new positive charge and here double bond. So in next step, these pi bond attack on this electron deficient carbon atom and there is a new formation of carbon-carbon double bond, carbon-carbon single bond and this positive charge. This is called as fusyl cation. In next step, after loss of this H plus, we get here double bond, here carbon-carbon single bond and this compound called as a fusyl. Instead of minus H plus of this hydrogen on 1,2 hydrogen shifting of this hydrogen on this carbon atom, we get here a new cation. So in next step, on addition of water molecule, we get here OH and on enzymatic oxidation, we get this moiety, here carbon-carbon double bond and this is called as fusyl. Now next we will see the synthesis of cineole from NPP. So first, write down the structure of NPP. So in first step, loss of OPP take place and we get allylic cation. So in next step, this pi bond attack on this electron deficient carbon atom and we get 6-member ring with this double bond and this positive charge. In next step, on enzymatic hydrolysis, we get here OH, here double bond. In next step, after H plus, we get here tertiary cation. In next step, this lone pair of oxygen attack on this carbon atom of carbocation and we get here this compound, here hydrogen, here positive charge. In next step, minus H plus and we get here this compound is called as cineole. This is also written like that. Here oxygen, here CH3.